Hello again. In the previous lesson, we finished trigonometric applications and models. Now we're going to move into the law of sines and the law of cosines. These laws help us to solve triangles that are not necessarily right triangles. In right triangles, we use sine, cosine, and tangent. But for non-right triangles, we often either use the law of sines or the law of cosines. So let's begin with the quick rules. So we have the law of sines, which is simply a divided by sine A equals B over sine B equals C over sine C. Now, what this says is we essentially have the length as the numerator and the angle as the denominator. Okay, and so these are across from each other. So if we have A on one side, the angle across from A will be sine A, and then so on and so forth. The law of cosines, this is the formula. And then when we use the law of sines, it's contingent upon these three things. We can either have angle, side, angle, 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 side, or side, side, angle information. If we have that, then we want to use the law of sines. The law of cosines, it's side, angle, side, or side, side, angle information. So depending upon whichever one we have, we need to use either this one or this one. Okay. All right, let's get started. So the first problem that we have, example number one, is we're going to use the law of sines as it's stated up here. But let's read the question. So it says, in the triangle ABC, we have angle, angle, side. Find angle C and side B, and then round the side lengths to the nearest tenth. So in this problem, we're given essentially two angles in one side, and that's a good situation for the law of sines. And then the first thing we need to do is find angle C, which as it is stated. So keep in mind, triangles in terms of degrees, they always add up to equal 180 degrees. Okay. That being said, we can take A plus B plus C and set it equal to 180 degrees, because we have this one, and then we can use that to solve for C. I'm going to rewrite this. So that's 42 plus 68 plus C was 180. This is going to give me 110. So I'm going to go ahead and skip the line and say C degrees is 180 minus 110. So the degrees for C is 70 degrees. Okay. So we have 70 degrees. Now we need side B. So we're going to use the law of sines. Now, side A is opposite angle A, as I mentioned earlier, and side B is opposite of angle B. So what we need to do is simply say A divided by sine A equals B divided by sine B. Okay. And then we can substitute what we have. We know A is 15. We know sine A is 42 degrees. We're going to set that equal to B. We're looking for B. Sine B is 68 degrees. Okay. Then in order to get B by itself, we simply multiply both sides by sine of 68 degrees. So multiply by sine of 68 degrees. Okay, sine of 68. By doing that, we would end up with B equals 15 sine of 60 degrees divided by sine of 42 degrees. All right. And then I'm going to flip this around. So what you can do is approximate this by putting it in the calculator. When you do that, and you put that in the calculator, you're going to end up with approximately 20.8 or 20 and 8/10. Okay, so we have our final two solutions. It says find angle C. We did that. Angle C is 70 degrees, and then find side B, and we use the law of sines to do that. Round the side lengths to the nearest tenth. When you get the calculator, you'll get a number, and then just round it to the nearest tenth. Okay. All right. Let's continue. All right. In triangle ABC, we have side angle. So we need to find the length of side C, and then we're going to round to the nearest tenth. Okay, so with this one, since we have side angle, or excuse me, or it can be also be referred to as side angle side, either way. Um, what we're going to use is the law of cosines in this one. So the law of cosines is an equation. It's c squared equals a squared plus b squared minus twice the length of two of those times cosine of capital C. All right. So what we'll do is we'll substitute what we have. We don't know c squared yet, or little c. So we have that. So it'll be 7 squared, 11 squared minus 2. And then 7 times 11 is just 77. So I'm going to go ahead and compute those two times the cosine of 48 degrees. Right. Computing further, we have 49 plus 121 minus 154 times the cosine of 48 degrees. Computing further, we have, that's 149, so that'll be 170. 170 minus 154 times the cosine of 48 degrees. You end up with 6, approximately 695, and you can put that in the calculator. All right, and then once we get there, notice we have to find the square root. C squared 65. C is approximately 8.2 in length. Okay, so the third side is about 8.2 units. Okay, and that's all we had to do is find C and then round to the nearest tenth. All right, let's continue. All right, this is the pause and try problem. Pause the video and try this problem. Okay, so we are given A is equal to 9, B is equal to 14, and C is equal to 18. That is side information. When we're given all three sides and need an angle, we use the law of cosines. For angle C, we need to use this form. Squared equals a squared plus b squared minus 2ab cosine of capital C. We can substitute the information that we already know, which is 18 squared, 9 squared, 14 squared, minus 2. That would be 9 times 14. Then the cosine of C, because we don't have that yet. Okay. Because which law should be used to find angle C? It would be this one right here. Okay. Because notice, once we compute this, we would be able to find the cosine of C as follows. But nevertheless, this would be the setup. Okay. And that's all we have to do. We can solve it, but we don't have to. It says set up the equation. That's all we had to do. All right, here is example number 3. Example number 3, in triangle ABC, we have A is equal to 10, B is equal to 13, C is equal to 16. Find angle C, round to the nearest degree. So we're given all three sides, and that is essentially side information. So we can find angle C by using the law of cosines as in the previous example. Okay, so now I'm going to show you how to solve the previous example using a different example. So remember that formula is C squared equals A squared plus B squared minus 2AC, or excuse me, 2AB cosine of capital C. Substituting the information that we already have in here, we have squared 10 squared 13 minus 2 10 times 30 cosine of capital C. So computing all of this, we have 256 equals, let's see, that'll be 100 and then 9, so that's 200 minus, that is 2, you do twice, that's 60 cosine of C. Okay, now we need to solve for the cosine of C. So what we do is we'll subtract 100, or excuse me, 269 from both sides, minus 9 equals negative cosine of capital C, right? Because I just simply moved this number over here by subtraction, and then once I subtract it from the right hand side, it's gonna obviously go away. That being said, when we subtract these two, we get negative 13. Negative 13 equals negative 260 cosine of capital C. Now we need to divide by negative 260, get cosine of C by itself. Now I'm gonna move over here so I have some more space. Once I do that, and I'm gonna just switch it around so we know the negative divided by negative is gonna be a positive. We're gonna have cosine of capital C equals, this is a negative divided by a negative, so it's gonna be a positive, 13 over 260. And then what we can do is simply find the ratio of that, or divide the two together, which would be 0.05. And then what we can do from here is use the inverse of cosine, right? So using the inverse of cosine, and so essentially the inverse of cosine would be written as C equals cosine of negative 1, parentheses 0.05, and this is inverse. Okay. And then we can approximate from there. So C is approximately 87 degrees. Okay. So angle C is approximately this, right? Let's look at the problem below, example number 4. It's a navigation problem. So two roads leave a town with an angle of 57 degrees between them. One car travels 40 miles an hour on one road and another 55 miles an hour on another road. How far apart are these two cars? So the two roads form the sides of the angle, right? Because they meet. And the distance between the cars is essentially the third side, right? So we know that two sides, excuse me, we have two sides and the included angle, which is essentially side angle side information. So we can use the law of cosines. So we need to let d be the distance between the cars, which we don't have. So essentially what that is d squared equals 40 squared plus 5 squared minus twice 45 cosine of 57 degrees. Then we can simplify from there. So we have d squared equals 1600 plus 3025 minus okay. Simplifying further, squared equals 4,625 minus 4,400 cosine 7 degrees. Then we can approximate that approximately 2,000. From there, we take the square root of both sides. D is approximately 47.2 miles apart, which is pretty far. Okay, so the cars are quite a distance apart from each other. Okay, now common mistakes, right? Capstone. A student pairs side A with angle B in the law of sines. Correct the side angle matching rule. So a triangle rotation, right? Each side is paired with the angle directly opposite it. So side A is opposite of. So essentially, the way we're thinking about it is this. I'm just going to sketch a triangle here. Suppose if we sketch the triangle, remember, law of cosines, law of sines is essentially dealing with like non-right triangles. So suppose if this was A, right? Then the opposite angle of A would be that. Okay. And then say this is B. Well, B would be here. And then this being C. So therefore, that would be C. Okay. So that's how you think about it. So we got sine A being the opposite here is equal to B over sine of B. Okay. So this is equal to this is equal to C over sine of C. Okay, so again, A and A correspond. B, capital B correspond. C, capital C correspond. So again, that is the law of sines. Do not pair side A with angle B unless the diagram specifically labels them that way, right? The standard notion is opposite matching. That's the point, okay? So opposite matches here, opposite matches there, opposite matches here. Okay, so that's the big idea. All right, the final review is this is the law of sines. Okay, and the law of cosines. The law of sines, you want to use this here. Okay, plug in what you know, simplify, um, cross multiply, and if you have to get one angle by itself, you know what to do. Multiply by the denominator on both sides to simplify. With respect to the law of cosines, this is the formula you want to use. The real world application that we did um, it operates the same way. Now, with respect to the law of sines, if you're given problems like this where it's like you don't know which one to use, well, understand what data you have. If you have angle, angle, side, then notice angle, side, angle, 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 side, or side, side, angle. So this is optimal for the law of sines, juxtaposed to side, angle, side, or side, side, side. Then you would use the law of cosines, which would be this equation here. All right, that concludes this video. Thank you again for watching, and I'll see you in the next one.